Here we're going to look specifically at some examples of piecewise functions and the different things that we can do with them. Now, a piecewise function is just that. It is a function that is made up of many different pieces. So what happens is you are given a function, kind of like this one here, and notice this one is made up of 3 pieces. And for each of these pieces, it has their own direction. So the direction would be this part right here, where we have the inequality. Okay, and with that, each has a function. And so these are the functions here. So what happens in a piecewise is you would look at this function as I have the equation negative 5x minus 8, and this equation only exists for x values that fall within this direction, where x has to be less than negative 2. You then have the equation or the linear line that you have 1/2 x plus 5, and this line again will only exist between negative 2 and 4. And then you have a third, 10 minus 2x, and this line here only exists when x is greater than 4. So you have to follow these directions very carefully when graphing or when evaluating. So here I want to evaluate. I want to find f of 4. And so the way I do that is I have to come into my directions and I have to figure out which one of these 3 equations this 4 falls into. So if you notice, this middle one here has the less than or equal to symbols. Therefore, my 4 is included in the second. So when we're looking at f of 4, we have to use the equation 1/2 x plus 5. Okay, and so that's where we're going to be. So here we would simply input the 4, so this is going to be 1/2 times my 4 plus 5. 1/2 times 4 is 2, plus 5 gives you 7. Okay, and that's it. That is the only equation that will satisfy f of 4. Now we have to use the exact same tactic to find negative 4. So we're going to look at the 3 equations again and figure out where negative 4 falls. And f of negative 4 is going to fall in the first equation, negative 5x minus 8. So here we're going to then input the negative 4 just like before. And what we're going to end up getting here is that we have negative 5 times negative 4 is a positive 20 minus 8 gives you 12. And again, that is all you would do. You wouldn't plug it into any other equation because it doesn't fit anywhere else. Okay, so that's evaluating a piecewise equation. Now the other thing that we can do is we can graph the piecewise equations. Okay, so I have some steps here that you can go ahead and read and reference. Essentially, for graphing a piecewise function, what you have to do is you have to graph each individual piece and only over the interval of which that piece is valid for. So you have to follow those directions very carefully again. Now you want to make sure when you are graphing that you use what are called the bounds. So the bounds are the points in the inequalities or in the direction. So you need to make sure that you use those regardless of the inclusion or not inclusion, meaning regardless if your inequality says just less than or just greater than, or if it has the equals underneath. Okay, so I have this example right here, so we're going to take a look at that. Okay, so here what we have to do is I have 3 equations again, and I need to graph each of these 3 equations on their own. So let's start with this top one here. So we're going to go ahead and we are going to set up our graph where we have x, and then we're going to use that y is equal to x plus 1. Now with this, the first thing we're going to use is we're going to use the bound, so we're going to use that negative 3. But then we also need to have another point, because this is a linear line, and linear lines need 2 points in order to graph. So my direction here says that x has to be less than or equal to -3. So I'm going to use -3, and then I'm going to use -4. Now the other thing that I know about -3 is this is where my inequality sign comes into play. My inequality sign in this case is equal to. Equal to means included. So one of the things that I like to do for myself is I like to put a little coordinate dot next to my number that's a part of it. And because it's included, I color it in, and what that does is it lets me know that that point is filled in instead of open. Okay. So now I need to figure out the matching y points. So here I'm going to have -3 plus 1 gives you a -2. -4 plus 1 gives you a -3. Okay. So I'm going to go ahead over into my graph, and I'm going to graph this. And I'm also going to color code it just to try and help you see it better. Okay, so in this case, the first point I have is I have the point -3, -2. So I'm going to come over 1, 2, 3, 1, 2, and it is filled in. So I'm going to darken this point in here. Then I have the point -4 and -3, so that's right here. I'm going to go ahead and connect these points. So I'm going to start them here, and I'm going to draw straight down in this direction, and there is my first piece. Okay. Now with that, I'm going to go ahead and label. So this right here was f of x equal x plus 1. Okay, so I know what I'm doing. Now I have 2 more lines that I have to do. So we're going to go ahead and look at the second one. So the second one here, I'm going to have x, and then I have y equals -1. And again, the first thing I'm going to do is look at my bounds. So I have the bound at -3, so I'm going to use that, and I have a bound at 4. I'm going to use that. Now, just like before, I have to determine what is going on at those bound points. So here at -3, notice my inequality does not have an equals underneath. So that means at my -3, I am open. I also have the bound at 4. Notice again, my inequality is just a less than, so I have an open point at 4. Now since this one had the 2 bounds already, I don't have to do any additional points. And this happens to be a special line. This is a horizontal line, which means both of these occur at the point -1. So if I go in and graph this, I'm at now the point -3, -1. So 1, 2, 3, 1, and this is an open circle. So I'm going to draw an open circle. And then I'm going to go all the way over to 4. So 1, 2, 3, 4, down at -1. And again, I'm going to draw it as an open circle. And then I'm going to connect between these two. So connect these dots right here like this. And there would be our second piece. So with that, this is going to be that f of x equals -1. Now the last one that I have is we have this bottom one. So here I've got x, and then y equals 1/2 x. My bound is at 4, so I'm going to start there. And then I need to have one more because this only has one bound point. So I'm going to use one more. Now since I'm multiplying by 1/2, I'm going to make it a little bit easy on myself. And so here I'm going to go ahead and skip 5 and use 6. Now the other thing that I know about it is that this point at 4 has an equals underneath. So I'm going to go ahead and fill in my circle. Now I need to figure out what my coordinates are. So here I'm going to have 1/2 times 4, which gives me 2, and 1/2 times 6 gives me a 3. So the last thing I can do is I can go in and I can graph these points. So I have the point 4, 2. So 1, 2, 3, 4, 1, 2. And it was a filled in circle, so I'm going to darken that one in. And then I have the point 6, 3. So this was 4, 5, 6, and 1, 2, 3. And I'm going to again, just like before, draw in my line. Now I'm choosing to use a straight edge. Obviously you would not have to. And if you're doing this on a computer, obviously the computer would draw the line for you. So the most important piece with these piecewise is creating your coordinate points so you know what to do. Now the last thing I would do here is I would go ahead and label that this is the f of x equals 1/2 x. And there you have it. That is all there is to it. Okay, so you've got an example where you have to evaluate your piecewise and where you have to graph. So if you have any questions about piecewise functions, please let me know. Again, remember the single most important piece is to make sure you include your bound points when you're trying to figure out what your coordinates are. So you include those bound points. Whether they were included or not included doesn't matter. Of course it matters when you graph it, but you have to use them when trying to figure out where those graphs actually are. So again, I hope you enjoyed this video, and I'll see you next time.